separating life on Earth from the rest of the cosmos is our atmosphere, a thin layer of invisible gases surrounding our planet like a blanket. When fossil fuels like oil and gas and oil are burned, releasing carbon dioxide molecules into the atmosphere. This is the possible that the other worlds. This is not like that. Warming the planet is dropping the balance into our climate cycle. Carbon dioxide molecules can stay in the atmosphere for centuries, slowly but steadily warming the planet. The natural world plays a critical role in slowing climate. Every year, about half of human-caused carbon dioxide emissions are absorbed by oceans and the world's vegetation, including crops and trees.
Trees consume this carbon dioxide. They eat it, restore and cool. 50% of the seed the tree is carbon.
And that's carbon that is warming the tree, or if it's cut down or decomposed, that carbon will end up back in the atmosphere as carbon dioxide.
By using trees over the long term, we can detect carbon.
We want to get a global picture of the amount of carbon that's stored in the forest. So what we're doing here is building a global network that maps, monitors, and measures forest carbon, and making that available to the world.
NASA, using airborne and satellite data, also looks at how forest changes impact carbon dioxide concentrations in the atmosphere. With these data, we create sophisticated models and data sets that help us track how carbon moves through the atmosphere, land, and oceans. Together, we are getting a better understanding of the global carbon cycle, covering the world 24 hours a day, 7 days a week. NASA collects data on carbon dioxide concentrations and forest ecosystems. But with all of this data, there is still more to learn.
Forests look different from states or from sunlight. So it's really important to have data that spans the range of forests that we're going to be able to build good models to predict forest projects.
First stage now pressurizing. We're coming up on the power transfer in a matter of seconds. This is Mars with the intro of the vehicle. T-minus 50 seconds. We have the power transfer. The vehicle is in general. The complete vehicle is not pressurized.
Hello everybody, coming at you from the Fernbank Science Center here in Atlanta, Georgia, and I have behind me the Apollo 6 command module from the Apollo space program back from the 60s.
Now being retracted from the second time vehicle. 25 seconds at a time. T-minus 20. Really time. Quick time. 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. 6, 5, 4, 3, 2, 1, 0. We have liftoff.
Flash flood and bomb cyclone. For 10 years, the joint NASA-JAXA Global Precipitation Measurement Mission has measured a lot. Satellite launched from International Space Station in early 2014, becoming the first satellite to be able to see fewer clouds and measure rapid and frozen precipitation from the equator to polar regions using a radar.
Hey. Yeah. Uh-huh.
Now we know that isn't true. Plastic pollution, overfishing, and a lack of understanding about our oceans
Okay.
contribute to the decline of our oceans.
Okay.
Time has come to change our relationship with our ocean. And your idea
Uh-huh.
of ingenuity can help us set sail on that new journey.
Okay. Thanks for letting me know. All right. Bye.
Imagine the ocean beyond. Because your passion, creativity, and innovation can help create a future with healthy, valued, and understood oceans for all life on Earth. Welcome to Team Ocean.
You want to look at some of the room, like, okay.
Well, I want to pitch for the council.
See like that.
We got one more to do.
All right.
billions of years, an interaction between ocean, land, and atmosphere has shaped our climate. A key part of this interaction is carbon dioxide, or CO2. In this view of Earth, we see carbon dioxide being absorbed through the seasons. The darker the green, the higher the concentration of CO2. When plants on land and phytoplankton in the ocean grow, they take in CO2 and release oxygen. This process is called photosynthesis.
You push the buttons yet?
Yes. We can smell them, but we not hear it.
You can smell it.
Yeah.
It's strong, isn't it?
Not that strong. You have
Oh,
to be very close.
Yeah.
它咬我。
We haven't seen the queen for a few days at least. Oh. Yeah. Can you meet the biggest one in there? I haven't seen her yet. Oh. Gonna like be one at least for a few weeks. So she must be hidden in here. I work here, so.
Oh, you work.
So she must be in here somewhere. But you might not be able to see her. I think they're gearing up to get a. There was a lot more babies in here, but I think most of them died. And then they're gonna. Or they're gonna hatch out a new queen at some point.
Yeah.
And then the next season. Have you checked outside yet? Have you seen the pond yet out back?
No, we went outside. We went outside for the restroom and also.
Oh, you want to see the pond and everything?
Oh, there's a pond.
There's a pond out here, out back.
Okay, let's. Most of the babies are on this floor, right? And
The exhibits, the planetarium downstairs.
yeah.
The planetarium downstairs.
Yeah.
I think that's still right now.
How about like the down this
I'm looking forward to. I'm confused.
It's behind there.
Well, how are we supposed to?
I guess it's closed.
I guess. Oh. Mm. I don't know, ma'am. This is my first time here too. You think you have to have a restroom for you to use? I'm gonna have to ask them up there, up front.
Hey, good morning. Welcome to Fernbank Science Center. Welcome back to you guys that are over here. And if you've been here before, welcome back as well. My name is Mark, and I'm the staff astronomers here at Fernbank. So what I'm going to do is start you off with a look at the nighttime sky. Not only right after sunset, but I'm going to take it a little later in the evenings as well to see some of the wintertime constellations that are easy to spot. So let me square up here.
We live on a colorful planet. We are surrounded by a colorful universe. Get set as we voyage into the world of color and beyond. Imagine the views surrounding you with no color, no vibrant reds, no luscious greens, no blue sky. Imagine if the planets were black and white. We are fortunate to observe and appreciate this beauty that surrounds us. So, how is it that we have this abundance of color? For example,
The sky is blue because the sun's light and the sky mix together. And it's like a rainbow prism thing. And all the colors get washed out except the blue. Or something like that. Come on, I read this in science class. Mars is red because of the iron in the rocks. The rocks get rusted, but for that to happen, there needs to be air. Is there air on Mars? Oh, I know this. It's because of the chlorophyll. Trees, plants, grass. It's because of the chlorophyll. But I'm not sure why chlorophyll is green or how that works exactly. But I know it has something to do with chlorophyll. Oh, I know this one now. Oh, I know that it's a gas plant, and it has these really cool rings. The color has to do with the atoms. The electrons in its color is, not quite sure though.
those were some very good answers. And yes, atoms, made up of protons, neutrons, and tiny electrons, are the incredibly small things that make up you, me, and everything around us. Atoms are ultimately responsible for color. For instance, let's go to the breathtaking Aurora Borealis, the northern lights. About 60 miles above the Earth's surface, sweet particles from the sun slam into oxygen and nitrogen molecules in our atmosphere. The collisions tear the electrons off each atom's nucleus. When the electrons fall back on the nucleus, they produce its pulsating photons of light. The shimmering aurora is sort of like a pinball machine. The silver balls in our cosmic arcade game represent particles from the sun. When they continually smash into all the bumpers, each collision produces a flash of light. If enough of these collisions occur, nature's pinball game pays off with an amazing display of light, motion, and color. When a beam of light, say from the sun, passes through a disperses into a rainbow of colors, the spectrum. Why? The sun's light is actually a mixture of all these wonderful colors, and each color has a different energy level. The glass prism slows down and bends or refracts each color differently. With a rainbow, it is the water droplets that look like a prism. The sun's light is first refracted entering the surface of the raindrop, then reflected off the back of the water molecule, and again refracted as it leaves the drop. One man who advances the science of light colors.
The rosette nebula. Look at all that gorgeous red gold. That's me. I'm red. Some say it symbolizes passion, love, bliss, maybe anger. Nebula like the rosette here. And the North American nebula, shining red because of the radiation from nearby hot stars that strip electrons off a bunch of loose hydrogen atoms. Those astronomers call that ionization. Isn't red just so radiant? Some stars are red and orange because they're slightly cooler than most stars. They're still hot, mind you. Another great example of red is Mars here. Okay, up close. It's a more tannish orange color. Mars is reddish because it's rusty. Mars has a lot of iron in its dust and rocks, and when that oxidizes, mixes with oxygen, you get shades of red. We also see red rocks on Earth made of oxidized iron, like when we lit the Grand Canyon. Don't you just love red?
Don't I just command attention? Of course I do. I'm yellow. I'm found throughout nature, in these exquisite sunflowers. And here in this canola field. And these stunning fall leaves. I'm way more than sweet. And don't forget, one of the most spectacular planets is yellow. Saturn's color is caused by the white ammonia haze that surrounds this globe, which is caused by its thick atmosphere, which is caused by its cold conditions, which is caused because of its great distance from the sun.
Gaze at the riches of me. Green. I represent life, vitality. You find me everywhere in nature. I'm bigger than the environment. Why is our world so green? The answer lies here, inside of plants. These big oval chloroplasts contain chlorophyll, which absorbs all the sun's color, except green, which bounces back to us. Out in deep space, the green glow of the Fernbank nebula comes from doubly ionized oxygen. And remember green from the breathtaking aurora. That's because of oxygen too. You know oxygen. This stuff we're breathing right now. Ah, the splendor of green.
Hello, I'm blue. Look how I've been cousins. And okay, maybe even sadness sometimes. Reasons for me on that. Take the blue skies of Neptune here, which are caused by methane. This gas absorbs the red and green parts of the spectrum, giving me cool blue to reflect back to your curious eyes. Another example is found here in the beautiful Pleiades star cluster in Taurus blue. The stars are blue because they're hot. Color pendants are A supernova remnant from long ago. I know, combination color, but folks tell me I merged the passion of red and the calm of blue. Wow, look at this violet gem, the Horsehead Nebula. Like the Veil Nebula, it glows violet because astronomers have combined filtered images of hydrogen, oxygen, and silicon. Gaze at the blossoms on this apple tree. And these lovely flowers. Pink, purple, plum, lavender, mauve, they're all part of me, violet.
We're not.
Well, it's been quite an adventure. Talking colors. Violet, I'm blue. Yeah, they do that. But they shared some of their causes, and we got to see their remarkable beauty. The electromagnetic spectrum spoke to us too.
I'm infrared.
And X-ray. And we learned much about the invisible universe, energy that races by us and even through us every day. Hey, stay curious, everyone. Keep exploring this incredible and colorful universe.
Alrighty, once again, thank you guys for joining us this morning at Fernbank. We certainly appreciate it and hope you have a wonderful rest of your day and great Thanksgiving. Be safe out there and do come back and see us again soon.
Yes, correctly. What are you doing? What I feel perfectly safe. Yes, I love dancing. Choose one of my dances on this display and let's go. Please step back half a meter and please make sure that I have enough space around me. I will dance for you freestyle. Thank you for your attention.
You can come back.
Thank you. Yes, I love dancing. Choose one of my... Please step back half a meter and please make sure that I have enough space around me. I will dance for you, Arcadia. you for your attention.
Thank you, Pepper. All right, let's go somewhere else. Eva.
Hey there, welcome to Fernbank Science Center.
Eva, come.
Thank you for coming to Fernbank. Would you like to hear some information about the Science Center? Please give me some space. I am doing big movements. I have practiced to work in a zoo. Until now I can do a gorilla, an elephant, and a mouse. First, the gorilla. Now the elephant. And now the mouse.
The ocean covers more than 70% of the earth.
That was fun. Thank you so much for your attention.
10% of the deep ocean has been seen by human eyes. Advances in technology are now allowing all of us to explore this inner space that
Yes, I love dancing. Choose one of my dances on the display and let's go.
the deep ocean is extremely challenging. In the beginning, we used diving gear.
Please step back half a meter, and please make sure that I have enough space around me. I will dance for you, Arcadia.
That came human occupied submersibles.
Thank you for your attention.
This map of the
Thank you.
Earth was created using large-scale satellite data. It reveals the irregularities of the seafloor and hints at amazing landscapes hidden in the
Whoa! It's awesome that you want to play with me. Select X or circle. X always starts. Here we go.
really looks like. A more precise system is needed.
It as a draw. Let's play again, please.
Sonar provides much more accurate detail on ocean depth. Multi-beam sonar works like this. Acoustic transmitters mounted on
Yes, I love dancing. Choose.
sounds called bands.
Please step back half a meter, and please make sure that I have enough space around me. I will dance for you freestyle.
Enter the seafloor and return to the ship.
Thank you for your attention.
To make vast underwater mountain chains. Huge canyons and trenches, some deeper than the Grand Canyon, carve a jagged path into the ocean bottom. Sonar pings bounce off bubbles escaping from cracks in the seafloor. These bubble detections have led to major discoveries of deep-sea vents and seas. Through the lens of multi-beam sonar, we even had our first look at previously undiscovered shipwrecks. Multi-beam bathymetric maps allow scientists to pinpoint areas of interest. Remotely operated vehicles, or ROVs for short, are deployed to further explore these deep ocean targets. ROVs are highly maneuverable underwater robots.
Goodbye.
You're connected to the main vessel by a flexible stainless steel tether, and you're driven by pilots on board the ship. There's no limit to how long an ROV can remain at depth. This ability to provide around-the-clock
Hey there, welcome to Fernbank Science Center.
Exploration. An ROV's powerful lights illuminate the dark, deep ocean environment. Hotspots of biodiversity can be protected as national monuments and marine sanctuaries. Vivid imagery of fascinating creatures is captivating and sometimes monstrous. And slowly progress the causing flooding and destruction in Madagascar and Mozambique. Over the course of the story's history, islands revealed a variety of rainfall features and trends that relate closely to the variations in plate temperature. For instance, many of the surface rainfall values can greatly differ relative to the 20th century, as well as the evolution When it comes to climate, what is wrong? It's a big question, but providing the best picture of what's actually happening is climatology, and D.Greene has made big strides in defining the annual cycle of precipitation climatology. D.Greene isn't alone. It stands on the shoulders of its predecessor, trends in tropical and variation. With trends launched in 1997, developing a fine scale of global precipitation and currents.
Finish up, okay?
To build the foundation of that knowledge. Today, GPM not only has added another decade of data, but reformalized trees with modern algorithms. This long and growing record was focused on a good estimate of what their minds and results should reveal in the current weather. They want to know how rain and snowfall will change, where extreme weather is, and how often. The data from GPM continues to help researchers build on a long record of past precipitation in order to set the stage for understanding vegetation.
John, I got some in the car.
Did you keep your penny that was smashed? Made that black for you? Another one from here.
Okay, well, they fixed it.
Yeah, you checked that filter.
And that's all that was it? The filter?
So you put some other stuff like together.
Okay, here's the garden. We're gonna go to the garden and we're gonna see if there's something to eat in this bag.
There's the whole go outside? You go outside by yourself? Okay.
Just find out. Just find out. Because my children cannot. Real riot if they have to. Oh, no. Real animals. Oh. Frightened me. I'm like, where's the snake? It's like right in my face. Poison dart frogs. Gotta go wash its skin.
Oh, wow.
Can we get a
Yes,
Yeah,
they're
they're
real.
real. They're alive.
Oh my goodness.
No hit in the glass.
Look at the snake.
No touching the glass, guys.
Yeah,
Do not touch the glass.
Ew. Princess, you can't block the way for everybody. You have a big head.
Yet we are increasing our population as if they were infinite. This fact is at the core of our environmental problems. On this map, we'll show population growth from the year 1 CE to the present, and project our growth into the year 2050. Population concentrations will be indicated by dots, each of which will represent 1 million people. In areas where people are spread out and don't live in concentrations of 1 million, dots are placed in the middle of their approximate range. Historical references will be provided by images and text at the bottom of the screen.
Our population is expected to grow to 10 billion by the end of the century. Yet the Earth's size remains the same. Slowing population growth and lowering our use of natural resources are key to reducing the impact we have on the planet. Through the decisions we make about our lifestyles, our numbers, and our consumption, we can all help preserve the health and beauty of our planet.
Coming soon to the Fernbank Science Center is our new AI lab, where we offer students an immersive, hands-on experience, helping them understand concepts behind AI and how these technologies are applied in real-world scenarios.
Our ocean, majestic, abundant, the blue heart of life on Earth, providing us with the oxygen we breathe, the food we eat, the water we drink. Without our oceans, life on our planet would cease to exist. And yet, our oceans are misunderstood, becoming overfished and polluted, and this threatens the very balance of life on Earth. How can we enjoy our modern world without destroying our marine world? Today, creative and passionate innovators, scientists, entrepreneurs, and people like you are using the latest technologies to solve the greatest challenges facing our oceans. And they all share one common belief, that together, we can create a world with oceans that are healthy, valued, and understood. For as long as mankind has roamed the planet, the oceans have provided us epic journeys, adventures, and a source for travel past known harbors. But our oceans remain a mystery. We have explored less than 15% of the ocean floor. Crushing pressures, extreme temperatures, and overwhelming darkness make exploring the deep ocean nearly an impossible task. It's hard to believe, but we have more accurate maps of the Moon and Mars than we have of our own seas. Right now, scientists, engineers, and organizations like NOAA are preparing for the last great exploration of Earth. And teams of innovators from around the world are competing in X-Prize competitions that spur innovation. Scientists predict that as many as 100,000 underwater mountains and literally millions of new species are waiting to be discovered. Will we find answers to our most elusive mysteries? Or discover cures to our most deadly diseases? Mapping our ocean will help us understand one of the greatest resources and biggest mysteries of our planet. Our ocean may be home to over 1 million species, from the largest animal on Earth to tiny zooplankton, all sharing the seas, living in a complicated ecosystem. But that balance is becoming more fragile every day because of the increasing dangers of overfishing. Big industrial fishing fleets catch more fish than the ocean can replenish, contributing to the depletion of precious marine life, with drastic consequences. Did you know that if the current rate of overfishing continues, by 2050, the world's fisheries may collapse, endangering the lives of billions of people around the world who rely on the ocean for food, medicine, and jobs? Overfishing could forever damage not only our ocean's health, but our own future. But there is hope. Scientists, innovators, and people like you are helping make our oceans more sustainable by creating technology like satellite tracking, allowing anyone with an internet connection to see fishing activity anywhere in the world, and giving authorities the chance to stop illegal fishing and protect special marine habitats. But we need your help too. When you eat fish, ask where it came from and check that it was caught responsibly to ensure sustainable fisheries. Preserving the health of our oceans is everyone's responsibility. The oceans are powerful and vast, covering more than 70% of the Earth's surface. They are active and vibrant environments where global wind patterns and the Earth's rotation create systems of currents called ocean gyres, circulating rich ocean water around our entire planet. This ocean conveyor belt is essential for regulating temperatures, salinity, and nutrients. But as ocean currents circle and converge, discarded plastics and trash collect in the 5 major ocean gyres. More and more, our oceans are coming under threat from humanity's garbage. 8 million tons of plastic enter the ocean each year, suspended from the ocean surface down to the depths of our seas. All that plastic breaks down into smaller, tiny pieces that harm marine life. Did you know by 2050 we could have more plastic in the ocean than fish? But innovators are developing cutting-edge methods to eliminate the threat of plastic waste by producing alternatives to plastics and even creating packaging products made from seaweed that don't harm our ocean. There are other ways to protect our seas from our trash. You can help keep our oceans clean, abundant, and healthy by reducing your plastic footprint. You can refuse before you reuse and recycle. Refuse unnecessary plastic items like straws and bags. Reuse water bottles instead of buying disposable plastic bottles. And buy food with less packaging like fresh fruit and vegetables. Together, we can keep our oceans clean for all the marine plants and animals that call it home. Because our ocean is so incredibly vast, we've allowed ourselves to believe that it's an infinite resource with the capacity to accept our negligence. But now we know that isn't true. Plastics pollution, overfishing, and a lack of understanding about our ocean has contributed to the decline of our ocean's health. The time has come to change our relationship with our ocean, and your ideas and ingenuity can help us set sail on that new journey. What ocean issues do you care about most? What cool technologies and amazing solutions will you create? Imagine the ocean you want, because your passion, creativity, and innovation can help create a future with healthy, valued, and understood oceans for all life on Earth.
See me up here?
Welcome to Team Ocean.
You can see me? I can see you. Can you see me? Can you see me?
I missed what you said. What was that?
20 cents? What 20 cents? I got a quarter. Turn left.
I didn't get that. Can you repeat?
How you doing today? How you doing today?
Sorry, can you say that again?
How you doing today? You doing okay?
I'm doing very well. Thanks.
All right.
Great. Thank you for coming to Fernbank. Would you like to hear some information about the Science Center?
For billions of years, an interaction between the ocean, land, and atmosphere has shaped our climate. A key part of this interaction is carbon dioxide, or CO2. In this view of Earth, we see carbon dioxide being absorbed through the seasons. The darker the green, the higher the concentration of CO2. When plants on land and phytoplankton in the ocean grow, they take in CO2 and release oxygen. This process is called photosynthesis. When these carbon-rich plankton and plants die, they are buried deep in the ground and in the bottom of the ocean, taking CO2 with them. Over time, some of that buried carbon becomes fossil fuels. Coal, oil, and natural gas. Our use of fossil fuels has transformed modern life. In this view, yellow is for urban areas, red is for roads, blue is for shipping lanes, and green for air corridors. We rely on fossil fuels for nearly everything, from transportation to building to food production. Every time we burn these fossil fuels, we take carbon out of the ground and put it into the atmosphere. Our energy use is radically tipping the carbon balance. Data spanning the last 400,000 years show that carbon dioxide levels have fluctuated. But during that time, CO2 always remained below 300 parts per million. In the 1950s, CO2 levels started skyrocketing, and they will soar even higher if we continue business as usual. This rapid increase in CO2 is dramatically changing Earth's climate and ocean. We are ill prepared for the consequences. Increased CO2 is changing the ocean's chemistry. Data collected from ships crisscrossing the globe indicate the ocean is becoming more acidic. Ocean acidification is beginning to dissolve the shells of many creatures, including those at the base of the ocean's food webs. The effects will ripple through our fishing communities to the billions of people that rely on food from the ocean for their survival. More CO2 in the atmosphere increases Earth's temperature. In this data set, the darker the red, the greater the change in average temperature since 1940. CO2 is a heat-trapping gas that acts like a greenhouse, keeping the air inside warm and moist. Warmer global temperature threatens plant and animal life. Blooming and migration cycles are changing. Coral bleaching events are becoming a common occurrence, destroying coral reefs around the world. Diseases that flourish in warmer weather are spreading. Warmer global temperature fuels more powerful storms, hurricanes, typhoons, and blizzards. It also makes sea level rise, greatly increasing the damage caused by storm surges. More extreme weather, both flooding and droughts, are becoming commonplace. Habitats are changing for all species, including people. In the Arctic, sea ice is melting, permafrost is thawing. Entire villages are being destroyed by coastal erosion. Arctic cultures that have been here for thousands of years face a precarious future, as do we all. But we can confront that future by taking a look at the past. "40 years ago, our use of certain manufactured chemicals was destroying the protective ozone layer in Antarctica. The global community came together to face this complex threat. Nations agreed to ban these chemicals, and today, ozone depletion has slowed. The ozone layer is expected to recover. Together, we can confront the carbon crisis. We have changed the Earth's climate and ocean by our actions, yet our actions can stem the tide. We can each commit to using less energy and to using it more efficiently. The same human ingenuity that made the Industrial Revolution can launch a new revolution, one built on sustainable energy, solar, wind, waves, even algae. The choices we make right now determine Earth's future climate. It's not too late."
You've seen volcanoes on land. Huge eruptions send up plumes of ash, and molten lava can stream over the landscape. There are more than 1,500 known volcanoes, but did you know that most volcanoes are underwater, deep in the ocean, and remain to be explored? Most of the volcanic eruptions on Earth are in the deep ocean. Where should we look for volcanoes underwater? Let's look for the newest volcano in the chain of Hawaiian Islands, Loihi. But how do we look? Here, the remotely operated vehicle, or ROV, Jason, is being deployed from a research vessel. Jason has a long tether or cable, that transmits video and allows pilots to control the manipulator arms. With Jason, scientists can sample the seafloor without leaving the deck of the ship. Loihi's summit is 1,200 meters, or about 3/4 of a mile down. Warm fluids vent from the summit at hydrothermal vents. These fluids contain iron, which provides energy to a special type of microbe, iron-oxidizing bacteria, that grow into rust-colored microbial mats, like a carpet on the seafloor. Scientists collect microbial mats using a suction sampler held by Jason. These bacteria are being studied for their role in chemical cycles in the ocean. Where else might we discover volcanoes underwater? See the large number of volcanoes that circle the Pacific Ocean? This is called the Ring of Fire. But the Ring of Fire also goes underwater. The stars show where deep sea vents have been found. Most of these are at underwater volcanoes. The Ring of Fire closely follows the Earth's plate boundaries. See how the vents line up on the red plate boundaries and are just offset the purple boundaries? Let's look in the Western Pacific at the purple convergent boundary where the Pacific plate is colliding with and dipping under the Australian plate. We'll head to a volcano called West Mata, where one of the first volcanic eruptions ever observed underwater was recorded. Listen as scientists discover the eruption at 1,200 meters, about 3/4 of a mile down.
Oh, look at that! I didn't get that. Can you say it again?
3 years later, the volcano was no longer erupting, but warm fluids poured out as hydrothermal vents. The ROV is holding a net to sample shrimp so scientists can learn where they may have come from to colonize the vent. Let's look again at the plate boundaries in the
Here's the latest from Earth Now. 3 out of 4 adults in America say that global warming is affecting weather in the United States. After Super Typhoon Haiyan made landfall in the Philippines, seen here by water vapor satellite imagery over sea surface temperatures, delegates at the United Nations Convention on Climate Change also made strong connections between climate change and extreme weather. But what does the science say? Is global warming changing weather patterns and weather extremes? First, let's consider some basic facts about weather and climate. Earth is a water planet. Oceans and lakes cover 3/4 of the Earth's surface, as depicted in this pie chart. Water is the only substance on Earth that exists naturally as a solid, liquid, and gas. The gas phase of water is referred to as water vapor. Did you know that water vapor is the most abundant greenhouse gas in Earth's atmosphere? While we can't see water vapor in the atmosphere, instruments on satellites can. This animation shows atmospheric water vapor detected by satellites, with moisture-rich air shown as white. Watch as storms in the mid-latitudes draw the warm moisture from the tropics. Weather patterns help redistribute heat and moisture around the planet. This means that the availability of water vapor fuels or limits all atmospheric processes. Let's take a closer look at how water vapor fuels tropical cyclones, also called hurricanes and typhoons. Rising air over warm ocean waters carries water vapor upward into colder air. As this happens, warm, moist air near the surface rushes in to take its place, creating the strong winds associated with hurricanes. As the warm air rises, the water vapor cools and condenses into clouds, releasing heat. The added heat accelerates the process. The rotating Earth causes the storm to begin spinning. Once a storm moves over land, it weakens rapidly, largely because the storm lacks the moisture and heat the ocean provides. Looking at typhoons and hurricanes over time, researchers see a trend. In a warming world with warmer oceans, there is more evaporation and more fuel for storms, leading to more powerful storms. The warmer air can also hold more moisture, meaning heavier rainfall. Finally, rising sea levels mean higher storm surges and more flooding. Basic science points to bigger storms, changing weather patterns, and more extremes. What does this mean for you? If you live near the coast, like a lot of people, there is an increased vulnerability to storms due to rising sea levels. Here, we can see Hurricane Sandy making landfall in the highly populated northeastern United States. Sandy caused an estimated $70 billion in damage in the U.S. But even if you don't live near the coastline, research shows that Earth's changing climate is altering the frequency, intensity, extent, and duration of other extreme weather events around the world. Wherever you live, it's important to understand the type of hazardous weather that might affect you and your family.
From year to year, the weather never seems to change. Great is not from the simple and permanent.
We need the long-term record in order to know how what's happening now is comparing to the averages of previous extremes. Basically, that's the climate. These data are important for how you expect variations that you perceive or perhaps your new
Thank you for your attention.
Y'all can actually dance.
Thank you for coming to Fernbank. Would you like to hear some information about the Science Center? Sorry, I didn't get that. It's awesome that you want to play with me. Select X or circle. X always starts. Here we go. It has a drum. Let's play again, please. Soraya circle. It's your turn. It has a drum. Let's play again, please. Okay. Soraya circle. It's your turn. It has a drum. Let's play again, please. Awesome. I prefer to be X. Please choose circle on my tablet so we can start. It has a drum. Let's play again, please. Okay. Soraya circle. It's your turn.
Oh, we got you.
Take us account. Let's play again.
Oh, you won't let him go twice.
Okie dokie. Soraya Circle, it's your turn.
You better get
No, how could that happen? Let's play again. Sorry, you win too.
You better take your chips before I Pepper is willing.
Soraya Circle, it's your turn.
So her name is Pepper.
Take us account. Let's play again.
I call it hardcore similar Welcome to hardcore similar
So on the sugar scrub microbeads, when the box that we're changing out, the microbeads, they don't dry completely out. They're
still damp around the edges. And we have a layer of sugar scrub in the bottom of the box, right? That I know she wants the packets out and stuff. I was going to suggest we put the layer of water beads on top of the sugar scrub so it would help absorb any moisture. She and I, yeah, she did. That's fine. No, it's good. Would you happen to have her contact number? Yeah. If you have it, just text it to me. I'll give her a number. Okay. All right, thanks. Yeah. Thanksgiving break, they're not here. Lydia's going to send me her number, and I'll call her.